All right, so problem solving in data lesson 3. With these problems, these are unit rates and conversions. And, as you're doing these problems, it's important to try and stay organized and write things out and then kind of think logically about some of the problems. Okay, let's take a peek at some examples here. Really no lesson to talk about here. Just discuss the type of problem you'll see via examples. If a 3-pound pizza is sliced in half, so right now you have a pizza, and this pizza is sliced in half, and each half is sliced into thirds. So now I'm going to take this piece and divide it into 3 pieces, then this piece divided into 3 pieces. What is the weight in ounces of each of the slices? Now right away, it's asking for the weight of each piece in ounces, right? So if 1 pound is equal to 16 ounces, the 3-pound pizza altogether would be equivalent to 3 times 16, which is 48 ounces, right? Now, if you think about it, if this whole pizza is 48 ounces, right, and there are 6 slices, now I'm just going to take the number of ounces, divide it by 6, and that means there would be 8 ounces per slice. Okay, I do think a diagram will help some, so keep that in mind. Now the next one. A partially filled pool contains 600 gallons of water. Right? A hose is turned on and water flows into the pool at a rate, so you know your rate is 8 gallons per minute. How many gallons of water will be in the pool after 70 minutes? So time is 70 minutes. Oh. So right away, you started with 600 gallons, right? But then you have to add the amount of water that was filled. So if I take 8 gallons per minute and multiply it by the number of minutes, that gives me 560 additional gallons. So if I take the 600, I add the 560, that means there will now be 1,160 gallons in the pool. All right. Now, the next one. This problem is a little more difficult, but critical to understand that if you write everything down, you organize yourself, it is a problem you should be able to get. It says the pes, a Roman measure of length, is approximately equal to 11.65 inches. So we know 1 pes is equal to 11.65 inches. It is also equivalent to 16 smaller units, smaller Roman units called digits. So 1 pes is equal to 16 digits. Okay? Based on these relationships, 75 Roman digits is equivalent to how many feet? So we need the number of feet to the nearest hundredth. That means 2 decimal places, right? So I look at this and I say, okay, I could do the long way where I go ahead and I set everything up. I know 16 digits is equal to 11.65 inches because 1 pes is equal to a pes. Now with this, I'll say, okay, I have 75 digits given to me. Now we're going to go through our conversions, and remember, any unit I want to get rid of, I have to put it in the denominator of the next fraction. So what I'm going to do here is I'm going to say, all right, I want to cancel out digits, right? So if I want to cancel out digits, I'm going to put 16 digits down here. That cancels out. Is equal to 11.65 inches. So now, in the end, I need this to be in feet. So now I'm going to multiply that by the conversion for inches and feet. So I know 12 inches, that cancels out the inches, is equivalent to 1 foot. So right now, this is technically over 1, and if I go ahead and I multiply all of these, then I multiply all of these, then I can divide. So 75 times 11.65, right here is how I do it in the calculator. I'm going to go 75 times 11.65, enter, is that 16 times 12 gives me that, 16 times 12 gives me 192. So now this ends up being 873.75 divided by 192. Okay, so now I'm just going to do 873.75 divided by 192, and it ends up being about 4.55 feet. Okay, because remember, the only unit I have left is feet. And if I round that to the nearest hundredth, this here is what we need to round to. Another way to quickly look at the problem is to say, if I have 75 digits, right, and it's basically 16, right now it's one pez is 16 digits, right? I could say that 75 divided by 16 would tell me that I have 4.6875 pez. And if I take that and multiply it by the number of inches per pez, which is 11.65, that would give me 54.609375 inches. Now, if I have that many inches, divide by 12, and you would get 4.55 feet also. You could also do it that way. So the next problem. Again, if you take your time and you read everything, it's not that bad. Tony is planning to read a novel. The table above shows information about the novel, Tony's reading speed, and the amount of time he plans to spend reading the novel each day. If Tony reads at the rates given in the table, which of the following is closest to the number of days, right, it would take Tony to read the entire novel. So when I look at this, it tells you he reads 3 hours per day. There are 8 parts in the novel. There are 239 chapters in a novel. There are 250 words Tony reads per minute. So he reads 250 words per minute. Now, there are 1,078 pages, right, in the novel. And the number of words in a novel is 349,168. So here's the thing, right? If he can read 250 words per minute, I know there are 349,168 words in the novel. And if he reads 250 words per minute, how many is he reading per day? Well, if this is in words per minute, what I have to do is say if he reads 3 hours per day, that means he's reading 3 times 60 minutes per hour. That means he's reading 180 minutes per day. So if he reads 250 words per minute for 180 minutes per day, right? That means right away the words per day would be 250 times 180. If I go to my calculator, 250 times 180 would tell me he's reading 45,000 words per day. Well, if I take the number of words in the book and I divide that by the number of words per day, so now I'm just going to take 349,168 and divide that by 45,000. that would mean it's about 7.75 days, which ends up being about 8 days total. Okay. Did you have to use every piece of information in that? No. All right. But you have to know what to use and how to use it. The next one. The distance traveled by Earth in one orbit around the sun is about 580 million miles. Earth makes one complete orbit around the sun in 1 year. Of the following, which is the closest average speed of Earth in miles, right? We need miles per hour. Well, to figure this out, what we're going to do is exactly that. We know how many miles already, right? Which ends up being 580 million. But now what we have to do is figure out how many hours are there in a year, right? So if I look at it, how many days are in a year? 365. Times how many hours in a day? 24. If I take 365 and I multiply it by 24, I get there's 8,760 hours in 1 year. So if I take 500 million and I divide it by 8,760, right away I go 580 million divided by 8760, hit enter, ends up being about 66,210 miles per hour. So that would be close to letter A. Next one. Coastal geologists estimates that a certain country's beaches are eroding at a rate, so the rate is 1.5 feet per year. According to the geologist, how long will it take in years, right, for the country's beaches to erode by 21 feet? So it's basically, if I look at this, I'm going to take 1.5 feet per year times the number of years. When I multiply 1.5 in the number of years, it has to be 21 feet. Well, if I go to solve for the number of years, just divide by 1.5, and 21 divided by 1.5 will give you y equals 14 years. So it would just be 14. Okay, next one. Seems easy. You got to be able to do it though. If h hours and 30 minutes is equal to 450 minutes, what is the value of h? Well, the first thing I'm going to do is subtract, right, the 30 minutes here. So 450 minus 30 is 420 minutes. Well, to figure out the number of hours then, remember, 60 minutes is equal to 1 hour. So if I divide this by 60, right, 420 divided by 60 will give me 7 hours, and that's what I would bubble in. Okay. And the next one. The weight of an object on Venus is approximately 9/10, so 9/10 Earth's weight. The weight of an object on, so that's for Venus, right? On Jupiter, right? The weight of an object on Jupiter is 23/10, right? The weight of Earth. Okay, if an object weighs 100 pounds on Earth, right, approximately how many more pounds does it weigh on Jupiter than it does on Venus? Well, here, what is 9/10 times 100, or 9/10 of 100? So if I go to my calculator, alpha y equals, I'm going to go 9 over 10, arrow to the right, times 100, that gives me 90. So if an object on Earth weighs 100, on Venus it weighs 90 pounds, and on Jupiter, I'm going to do 23/10 times 100. Now I could do that in my head real quick, but if you're not good with that, go alpha y equals 23 over 10, and then multiply that by 100, and you get 230. Well, if it's 230 on Jupiter, 90 on Venus, when you subtract them, the difference is 140, letter C. So the peregrine falcon can reach speeds up to 200 miles per hour, all right, while diving to catch prey, making it the fastest animal on the planet when in a dive. What is the peregrine falcon's max speed while diving to catch prey in feet per second? So now what we have to do is change this from 200 miles an hour to something feet per second. So we already know that 1 mile is equal to 5,280 feet. So that'll be an easy conversion. But if we got to get from hours to seconds, right? That's what I want to kind of focus on here. If 1 hour is equal to 60 minutes, and then 1 minute is equal to 60 seconds, can I say that 1 hour is equal to 60 minutes per hour times 60 seconds per minute, right? Therefore, it'd be 3,600 seconds per hour. So 1 hour is equal to 3,600 seconds. So now what I'm going to do is come over here and I'm going to say 200 miles for every 1 hour times. First thing I'm going to do is eliminate miles and convert that to feet. So remember, I need miles to cancel out. So 1 mile, these cancel, is equivalent to 5,280 feet. So right now I have feet left. But now I have to convert that hours, right, to seconds. So times 1 hour has to go on top to cancel the hours out. Over, we need 1 hour is equivalent to 3,600 seconds. Now, when I multiply the numerators, right, you get 1,056,000, right, divided by 3,600. When you divide that, you end up getting 293.33. And if we round this to the nearest whole number, that means it would be 293 feet per second. And you only have to put in the 293. Okay. Now, the last one, if a peregrine falcon dove at its max speed for half mile to catch prey, how many seconds would it take to dive, right? Well, you know you go 293 feet per second, and 1/2 mile would be equal to 5,280 divided by 2. So that falcon would end up going 2,640 feet to get the prey. Well, if I take the 2,640 divided by the feet per second, right, that would give me approximately 9 seconds to catch the prey. So the answer would be 9.